So remember that the cube root never has any restrictions. So the domain of function g is all real numbers. But that's not the case for g prime, because g prime has a denominator. G does not. But g prime has a denominator which can be 0 when x is 2 or negative 2. So these are critical numbers already, coming from g prime being undefined. G prime equals undefined when x is 2 or negative 2 because the denominator is 0. Now, where does this, when is this 0? So another critical number will be from the numerator, which is x equals 0, also a critical number, coming from g prime equals 0. So always remember to look at both sources. So one source is when g prime is 0, the numerator is 0 only when the top is 0. But also only because the function is defined at 2 or negative 2, it's 0. Otherwise, these would not be critical numbers. If the function is undefined at positive or negative 2, of course, they're not critical numbers. But the function is defined at 2 or negative 2, but the derivative is not. So remember, there are two possible sources of critical numbers. One from g prime being 0 and the other one from g prime being undefined. So the discussion about critical numbers stops here. Now, if there is an extra question, like identify if these are max-min, then that's a different question. So let's proceed with that, because I want you to understand that this is very important. Right. So here's x, negative infinity to infinity, and I have negative 2, 0, and 2. I have g prime, and I have g of x. Now I have 0. I have undefined, undefined, and 0. So I have to study the sign of the derivative. But I notice that this is squared, so this quantity will always be positive times 3. So this will not make any difference. This denominator is always positive. So only the numerator will give us a different sign, right? Or the sign of the entire function. When x is negative, the entire function is positive, because negative 3 with negative 2 or negative 5 with negative 2 will be positive. And if x is positive, the whole thing is negative. So here I have 0, 0, and at 0 I have the cube root of 4 for the function values. And these two are not max-min. Okay? This is the only one that changes into a max, a relative or a local max, or local, same thing. Okay, so here the derivative does not change sign. So negative 2, 0 is not a max or a min. Here the derivative does not change sign. Oops. So 2 comma 0 will not be a point of extrema. Only here at 0 comma the cube root of 4, the derivative changes sign and it's 0. And this will be a relative max. Positive going up and coming down. But if the question is only asking us to identify the critical numbers, this is not required. But if part 1, for example, says find the critical numbers, and part 2, or any of these change into max-min, then you have to study and do this work. Good. Other questions about anything?
How did how did you get the cube root of 4?
I have to plug in negative 2 in here and get the function value at negative 2. I have to plug in 0 and get the function value at 0. And I have to plug in 2 because without these values, I will not be able to eventually graph. See, when x is -2, the function is 0. When x is 0, the function is this.
I see.
And when x, so these are, that's what I'm saying. I always, that's how very easily, I don't need anyone to tell me my mistakes or point out. If the chart, if the table does not go smoothly and the signs are not correct when the function is increasing or decreasing, then I'll say, oops, and get back and dig my mistake, dig up my mistake. But without the table, I will not be able to. It will take me much longer to find the error. Anything else?
Can we try to look for concavity?
Yes, of course. For which? For this one or something else? Or
This problem's okay.
okay, so let's take a look. So concavity, I have to determine the second derivative, and I'm going to massage it a little bit. So I'm going to differentiate -2/3 outside, and then x times 4 minus x squared to -2/3. This is what I'm going to differentiate. Why? Because I want to make my life as easy as possible. So I have -2/3 outside, I have an x, and I have this quantity here. So always try to simplify this, because if you keep the -2/3, you make it more difficult. The numbers are getting bigger, who knows what. Okay, so -2/3. When I differentiate the first function, I get 1. So then 4 minus x squared to -2/3. And then plus, I keep x, but I differentiate this by bringing down -2/3. X, I'm sorry, I have to write 4 minus x squared first. To -2/3 minus 1, which is -5/3, and times -2x. That's not a friendly function, but we have to continue. Since we started, we have to continue. So -2/3 is outside. When I differentiate x, I get 1 times the second one plus x. And then when I differentiate this, I bring -2/3 in front. I write 4 minus x squared to -2/3 minus 1 times the inner function prime, which is -2x. So now I'm going to try to clean it up. Okay, 1 over the cube root of 4 minus x squared squared. Positive 4/3 x squared. X and x, positive 4/3, 1 over the cube root of 4 minus x squared to the 5th. Okay. This is what I would do next. This is not an easy situation. I see that the cube root of the same quantity squared, the cube root of the same quantity to the 5th power. I will factor out the one with the smallest power, which is the cube root of 4 minus x squared squared. Put it in front. So I'm at -2 over 3. The cube root of 4 minus x squared squared. This is 1. And this is plus 4x squared over 3. And what is left, there are 3. 3 and 3 is 1. 3 over 3 is 1. So 3 in front. And 4 minus x squared. Without this technique, remember, always factor, simplify. This has to be in the back of your mind at all times. Now, this will never be 0, so I shouldn't even focus on this, because we want to find concavity. We want to find inflection points. So I have to set this equal to 0, okay? Because this will never be 0. Why? The numerator is never 0. A fraction is 0 when the top is 0, but this is gone. So when I set this equal to 0, when I set g double prime of x equal to 0, this has to be 0, if anything. So 3, 4 minus x squared plus 4x squared over the denominator, set equal to 0. I found the least common denominator. This is 0 only when the top is 0. And I have 12 minus 3x squared plus 4x squared equals 0. So this is, so x squared plus 12 will never be 0, never. So as you see, there are no inflection points, but now we have to think in terms of, so the numerator will always be positive. One more time, 12 minus 3x squared plus x squared. X squared plus 12 is never 0, it's always positive. So now I need to study the sign. So I'm just going to rearrange this function one more time here to discuss the sign. So -2 times x squared plus 12, because that's what I had, over 3, the cube root of 4 minus x squared squared times that denominator, times another 3, and times 4 minus x squared. Okay. One thing is for certain, that these are always positive. Don't erase them, you know what I mean. So this, there is no need to study the sign of this piece. Always positive, always positive, always positive, always positive, always positive. This and this will give the sign of the second derivative. So in between solutions of the -2 and 2, because it's undefined, of course, the second derivative. If the first derivative is undefined there, the second, all the other ones will be. Okay, so when x is 0, this is positive, but there is a negative in front. At 10, this is negative with positive, with negative. And when it's -10, the same thing. So it holds water, it does not, and it holds water, which makes sense because this is a maximum. How can it be a maximum if it holds water? So it has to be like this by the second derivative test. So it has to be like this because it's a maximum. So holds water between -infinity or concave upward to be correct. Between -infinity and -2, union 2 to infinity, and it's concave downward between -2 and 2. But this is a lot of work. This is a lot of work. Especially if you don't factor, that's going to be a mess to simplify and find the that's what we do in pre-calculus a lot. We review with our students how to factor factor out the factor with the smallest power from terms that have a common factor. Any questions? So I factored out the smallest power. This was power -2 and this was power -5, but I changed them into positive. So now 2 is the smallest versus 5. So that's how I factored out this. So you understand that this times this, which is the cube root of 4 minus x squared cubed. So this times this will give us this. And this times 1 will give us that. Again, please remember factoring, because this would have been a bigger mess with -2/3 in there. So what I would do, whatever function I'm asked to graph, I will simplify it immediately. So if it's a rational function like x minus 1 over x squared minus 1, I will immediately do this. Do not simplify before you state the restrictions first, and then I will simplify. No matter what function you give me and you ask me to graph, the first I will look at the function and say, where do I start? And the answer is simplify if I can. factor and simplify if I can. That would be the first thought. Any questions? So I'm sharing my screen for a second. I was going to work on this problem. Just let's give me 1 second on this problem just to show you something, and I'll stop after that. I know I talk too much, forgive me. So h of t equals t to 3/4 minus 2t to 1/4. Okay, so on this problem, I will immediately factor out t to 1/4. Because 3/4 minus 1/4 is 2/4, so this is the square root of t basically, and it's minus 2. So if you want to find the x-intercepts, for example, h of t is 0, I know that this is the 4th root of t to be 0, or the square root of t to be 2. From here I have one option, and from here when I square, I have t equals 4. It would be more difficult to try to find the x-intercepts without factoring. Actually, I wouldn't know what to suggest if you don't factor. Maybe change it and see how to factor that way, I'm not sure. So the idea is always simplify the function. So I realize that the smallest power is 1/4. I pull it out. 3/4 minus 1/4, I mean this 3/4 minus 1/4 is power 1/2, right? So 3/4 minus 1/4 is 2/4, which is 1/2, which means the square root of t. And this is the 4th root of t equals 0. So there are two options. Either this is 0 or this is 0 for the x-intercepts. So I get 2 x-intercepts right away, which is also the y-intercept. But no, I will not differentiate this. Of course, I will differentiate this form. So every form has its importance. This form helps me find the x-intercepts in a blink, but this form is the best for finding the derivative. So always, please remember, if you don't get a lot from this class, which I know you do, you got a lot of information and you learned a lot, always remember factor simplify are crucial in everything you do in math. There's a difference between making a difficult problem into a